Hello everyone, welcome to our afternoon session of the CNPS 2019 conference. Our speaker today will be Roger Anderton with the subject Einstein Mistranslated. So Roger, take it away.
Okay, thank you. Thank you for allowing me to do this talk. It's called Einstein Mistranslated. Click on that. So, introduction. We in the Natural Philosophy Association, which became the Chappell Natural Philosophy Society, have been pointing out for a long time there's problems with Einstein's relativity since our founder, John Chappell. There's problems being pointed out with the maths, philosophy, methodology and so forth, but there doesn't seem to be much on the issue that Einstein has not been translated properly into English. So to try and get into that, there are no references in Einstein's paper on special relativity, and this is one of Einstein's friends called Max Born. And Born says that it gives you the impression of quite a new venture, but that, of course, as I have tried to explain, not true. So he's explaining that Einstein's paper on special relativity in 1905 is not a new venture. Einstein is working from other people, but unfortunately, Einstein does not give references, so it's not clear what he's working from. So Einstein's paper on special relativity, 1905, is called On the Electrodynamics of Moving Bodies. It has no references, citations, and so we want to find. So it gives the false impression that it's from Einstein's imagination alone through his thought experiments. And so we need to work out really the tradition of relativity pre-Einstein from which he was working from. Now Galileo talked to relativity, and between him and Einstein there were many others who dealt with relativity, but most of them may get ignored because they're overshadowed by what Einstein says. When we look at Einstein in the original German, we encounter problems such as this German word can translate into English as either velocity or speed. You've got that sort of problem with other German words. They don't translate one-to-one. The German word can translate into various different English words. So you've got a translation problem from German into English. So when Einstein is talking about a constancy of light speed, or is it constancy of light velocity? So that's one of the problems you get when you try to translate it. It's an example of many problems in translation, and when he's talking, I think he's talking about light speed constancy and not light velocity constancy. But in some of the translations of Einstein, they're saying it's light velocity constancy. Ideally, Einstein should have clarified what was translated, but what seems to have happened is that he relied on his translators and he didn't check. He was too busy with other things such as politics. Now, the politics he got involved in, he was supposed to hit that, and that took a lot of his time, and he got involved in the atomic bomb, politics around that. He didn't want the atomic bomb to be used, so there's lots of political issues he was getting involved in, and that was diverting him from doing physics. He wasn't spending 100% of his time on physics, and I don't think he was doing the proper job of checking what's being translated from German to English was being done properly. So now I have two translations that I can compare of what Einstein's saying. The usual translation of Einstein is by Perrott and Jeffrey, and I'm denoting that as OEM. OEM stands for on the electrodynamics of moving bodies. And this has been published in places like Principal Relativity, a collection of original memoirs on the special and general theory of relativity, which includes Lorentz, Einstein, Minkowski, and so forth. Now, the translation I'm comparing it to is by this person, Crackler. He's written several books translating Einstein from German into English. And in this particular book, he's translated the 1905 paper on special relativity. So this is Crackler. He was a software engineer for McDonnell Douglas brackets NASA, and I think he's retired since. But I think he's fluent and in German and English. So I'm going to compare these two translations, the OEM translation, which is the usual translation of Einstein, with Crackler's translations on denoting AFK. And my conclusion is the usual translation is awful. And that's the translation that everybody goes by. It's awful. It's just bad. There's too much bad in the usual translation of Einstein. If you go back to the original German and do a proper translation, you don't get the same theory as what everybody is being taught is Einstein's relativity. So you've got the German version of Einstein and the English version, which everybody goes by. That's all bad. It's not the same thing. So we're going into looking at now. This is in the OEM version, the usual translation. It says, let there be in motion in an electromagnetic field and electrically charged particle in a sequel called an electron for the law of motion, of which we assume as follows, and it gives the maths. Whereas the other translation I get, he says, it's translated as suppose that an electromagnetic field acts on a point particle with charge, epsilon, here denoted, an electron, for which the following laws govern its motion are. So the difference between the two translations is, in the better translation, you've got the words point particle, but in the usual translation, you haven't got the words point particle. So you look at the German, he's using Punt-Toffik things, which probably translates best as point-like, and the other word German word translates best as particle. So in English, it's point-like particle or point particle. So in the German, he's talking about point particle, but in the usual translation of Einstein, he's not. In the bad English translation. And in various places, the term material point is used, which is another way of saying point particle. Thus, Einstein's paper on special relativity is dealing with point particles. Point particle is the theory of Newton. When you have something like gravity, such as between Moon and Earth, it's treated as an idealization of point particles. The distance r is between objects, is really between their point centers. This is Newton. And this is the point particles here, the point centers. Point particle is the theory of Newton and was developed further by Boscovich. The basis of Einstein's 1905 paper on special relativity is thus Boscovich-Newton point particle theory. So now we have a connection to special relativity from an earlier tradition is to deal with point particles. Now, based on the usual translation of Einstein, is not making that clear, as it's not translated the term point particle. So, I'm into Boskovich's theory a lot, and my contact for the expert on that is this person, Dragoslav Stokovich. Now, Boskovich's theory deals with a hierarchy of matter, starting from the bottom elementary points, which are point particles. Then they form into first order particles, and then on to second order particles, and so forth, until you get atoms, and further on that you get molecules. And they'll obey this force law curve. And this is the book at the bottom here, is the book dealing with it from Dragoslav. It's called What Boskovich had found in modern science. And I'll also have a paper by Augustus Prince. It's called An Electrical Form of the Boskovich Curve with Applications at this web address. So back to comparing translations. In the usual translation, it says 1, the laws by which the states of physical systems undergo change are not affected, whether these changes of state are to be referred to the one or the other. The two systems of coordinates and uniformly translatory motion. And the other translation, AFK translation, is giving you this. They are similar in the context of this, but in the context of this, we must be dealing with point particles. So this sentence, whether you go by the usual translation or whether you go by AF, you're now talking about point particles. And so it refers to uniform, and uniform can apply to acceleration. You can talk of uniform equations of motion of Newton, and that deals with uniform acceleration as well as uniform velocity, or speed velocity. Probably best say uniform speed. So it's not been made clear to people that special relativity is dealing with acceleration as well as speed of point particles. So these are the equations of uniform motion for point particles, and they're dealing with uniform speed, and they can deal with uniform speed and they can deal with uniform acceleration. And these are not what taught people when they're taught Newtonian physics. So what might have obscured this a bit is from the usual translation, it says, let's take a system of coordinates in which the equations of Newtonian mechanics hold good. And it has a footnote to that, i.e. to the first approximation. Well, the AFK translation doesn't have the footnote. There is no first approximation. So that's another main difference between the German and the usual translation of English. The English translation is telling you something which is not in the original German. The first to state in Newtonian physics, NP, as an approximation of special relativity, and I denote that NP with the approximate equal sign to SR. While the second is stating NP equals SR. So you've got two different theories. The first theory is Newtonian physics is approximately equal to special relativity, while the second theory is Newtonian physics is special relativity. When you go back to the original German, there is no footnote. The footnote was added by the translation of the OEM version without justification. So really a proper translation is its MP was SR, i.e. Newtonian physics equals special relativity. And it's not that Newtonian physics approximation to special relativity. That is a mistranslation to think that Newtonian physics is an approximation to special relativity. Now, however, most people would think Newtonian physics and SR do not look the same. Mainly, this is because of the time dilation issue I'm now going into time dilation. But I'm pointing out special relativity is really Ostrich Newtonian physics. Oh yeah, so getting to the issue of mass, in the usual translation, we get this passage: in agreement with the experience, we further assume the quantity to be a universal constant, the velocity of light in empty space, and it gives this equation. Now, the velocity, as I've already mentioned, should be better called speed. So it should be saying, in agreement with the experience, you further assume the quantity to be universal constant for the speed of light in empty space rather than velocity. So the usual translation corrected with the word speed instead of velocity is that. Now if we contrast that with what AFK says, he says further, we take it that the quantity is a universal constant, the two-way speed of light in empty space. So AFK interprets Einstein as he's talking about two-way speed of light, where rather than the usual translation of OEM, there is no mention of it being two-way. Now, the two-way is in brackets, and it's AFK's interpretation that Einstein's talking about two-way. In the actual German, there's no mention of two-way. Whereas if you go by the OEM translation, you're interpreting it as talking about one-way speed of light. So you've got the difference of one-way speed of light versus two-way speed of light. Now, if you're talking a two-way speed of light, it brings it more in line with Newtonian physics. So I deem it a mistake to think it as one-way speed of light. What you can get from the two-way speed of light case is, given a person observing light go in one direction of speed, c minus v, then we bang and go with speed c plus v, whereas this a very normal addition of speed as per Newton, and for v greater than 0, then c minus v is less than c, and c plus v is greater than c, i.e. the one-way speeds can be less than or greater than c. So the one-way speed of light is not constant, whereas what we can do for the two-way speed of light is we can add the two one-way speeds of light and then divide by 2. And this is the bottom equation here. If you add the two one-way speeds of light, then you get C. So from that, the one-way speed of light is not constant, but the two-way speed of light is. That's the equation written again. C equals constant equals two-way light speed. Thus, we still have Newtonian physics. One-way light speed is not constant, just a strange convention of a two-way light speed being introduced. And when we look at the maths before what AFK says about two-way speed light, he seems justified in saying it's a two-way light speed. Just that Einstein does not use that terminology in his paper. So, going on to the time dilation thing, this is the time dilation equation. When the belief was that Newtonian physics is an approximation of special relativity, this equation was believed to be special relativity and meant that as V tends to 0, i.e. much less than C, it approximates to being Newtonian physics. But that was wrong. Actually, this equation is a Newtonian physics equation. It is not that it approximates to Newtonian physics. This is Newtonian physics, this equation. So, we need to check. This is highlighted when you read what Newton has to say. Newton does have variable time. If you go to this place here, it's cited Stanford for Scientific Philosophy. It says Isaac Newton founded classical mechanics on the view that space is distinct from body and that time passes uniformly with regard to whether anything happens in the world. For this reason, is both absolute space and absolute time. So it distinguishes these entities from the various ways by which we measure them, which we call relative space and relative time. So Newton does have relative time. So time dilation is okay with Newton. He does have absolute time and he does have relative time. So now some people think that Einstein denied the existence of absolute time. But when you look at him, he doesn't talk of a common time, and that might be related to absolute time. In the usual translation we have not defined common time for A and B, that's two observers and clocks. For the latter cannot be defined at all unless we establish by definition that the time required by light to travel from A to B equals the time it requires to travel from B to A. AFK translates this as this latter common time can now be defined in terms of the time that light takes to go from A to B and its equal return, i.e. to the time from B to A. And so this is the difference. These are the differences in the translations. In the usual translation, you've got cannot and unless, and in which I think is the better translation, you've got the words can now. And I'm going to pass back going into details about that, but I've written quite a lot about that. And basically, they seem to be allowing it by definition. Then we have concepts of like universal time taken up later. Universal time, and this is from Wikipedia, is a time standard based on Earth's rotation. It's a modern continuation of Greenwich Mean Time. So we do have universal time. And universal time implies a universal frame similar to the concept of an absolute frame, i.e. is a defined frame chosen to be a universal straight absolute frame. Postgrid's theory is point particles with action at distance by fields and these particles not coming into contact. If thinking in terms of a mechanism of particles interacting by contact, then it seems to be the Lasarge theory. And Postgrid's theory used to be taught until Einstein and quantum revolution, then it was dropped to make room for them. So developments in physics have been lost to those that are taught physics nowadays. I feel I should, now we're getting on to conclusions. Einstein seems to rely on his translators to translate his German into English, and his translators did a bad job, and that's his usual translators. The ones that have done the usual translation of Einstein have done a bad job. If you go to this article, June 2019 issue of Physics World, it points out Einstein wasn't good at English. Einstein lectured in the 1930s in Oxford, England, and he spoke German to everybody, not English. And that might be a reason why a lot of the audience had difficulty understanding him. And this is a blackboard from Oxford, being kept as a souvenir of his lectures. So much of what's commonly said about relativity is based on the bad translation. The context of Einstein's relativity from an earlier source was lost by the bad translation. The earlier source being given. We have other issues such as there are mistakes in the maths of Einstein's paper, which have been brought up by many people. Einstein's innovation was supposed to be of dealing with light as particles in his 1905 paper on the photoelectric effect. Light was being dealt with by most of his contemporaries at that time as a wave, and Einstein reintroduced the old idea of light as particles forming. This led to wave-particle duality concept of quantum mechanics. And now, as emphasised in this lecture, his relativity was also based on particle concept, i.e. his relativity was built on the Boss-Newtonian point particle physics, but because of bad translations from German into English, that has been obscured. Hence, a proper appreciation of relativity has not been taught. It has not been properly appreciated that Einstein's two major papers of 1905, photoelectric effect, which led to quantum mechanics, and his relativity paper, were both dealing with light as particles. So, i.e., his relativity and what became quantum mechanics was unified in 1905, with both being based on particles. Einstein's two papers were unified and both being about particle theory of light. And that is contrary to how it is now taught, with there being a schism between relativity and quantum theory. For Einstein, the two things were unified in the German, but they got lost in translation into the English. Finn, that's it. Any questions? Thank you.
Okay, anyone got any questions for Roger?
Ooh.
Before we go, whatever it has.
We're gonna get feedback, sounds like.
Basically,
I have a question.
special relativity
Hello.
is Newtonian physics.
Hello?
Being translated from.
Do you hear me, Roger?
Yes, thank you.
This doesn't seem to be that loud. Hello, 1, 2, 3. Weird. Yes, this is David D. Hillster. Have you talked any with Dr. Edward Dowdy about this translation problem?
No, I haven't talked with him. I've tried to talk to other people who are fluent in German and English, and one of the people I know is Anton. He doesn't think it's important that the German hasn't been translated properly into English. He thinks you just go by the maths. But I've looked at the maths, and the maths is a mess. And so I want to make sense of what Einstein's really saying. And then I found out the English what he's saying in English is not proper to what he's saying in German. So you've got the added problem of the maths being a mess, and it's not being translated properly into English. And there's loads of other problems as well, and this has been going on for a long time, with a lot of us complaining that Einstein's relativity isn't right. And what's not been emphasised is that it's not been translated properly. So everybody's talking about the wrong theory. It's not the same theory as what Einstein was talking about.
Yeah, because actually this is the same type of thing that Dr. Edward Dowdy has said. He has said many times in his lectures, or that I have seen, that he speaks and reads fluently German, And he says a lot of he also mentioned, I'd be curious about, that since you've taken a look at it, he made this comment, I remember, in general a couple times, that what he noted is that the translations in English seemed much more certain in their wording of things, and where the German was a little bit more softer, maybe more ambiguous, less confident, but not in a way because Einstein would be less confident, but in a way that was more of a humble kind of way of saying it, and there's sort of an arrogant translation. I'm putting these words in the mouth, but that's what it sounds like Dr. Dowdy was trying to get across, that if you read it, it's more open in German to interpretation of really what he was saying, and that about the absolutes, etc. Is that something that maybe you found, or?
Yeah, I found that there's when you go through Einstein's 1905 paper, comparing the two translations I got, one of the usual translation is Einstein proving there's no ether, and then the other translation, which is better, he's not saying that. He's saying it's not necessary to have the ether. And so if it's not necessary, you've got the option, you can put it in if you want to. And Lorentz's theory is much the same as Einstein, but it's got the ether. And so special relativity, properly translated, is more in line with what Lorentz is saying about that issue of ether. So all this stuff about is there ether or isn't there, it's all based on mistranslating Einstein once again.
Yes. See if it's on.
Very interesting.
Well, hold on, it's not high enough. Just a minute, we're going to get this a little higher here. Go ahead, say something there.
Mark, 1, 2, 3. Musa?
Hello? Yes?
Okay, it's better.
Yes.
Hello.
Very interesting talk. Is there any attempt now to correct the mistranslation of Einstein from German to English? Do we have some literature where this has been corrected?
I've put a load of papers on the General Science Journal about my translations of Einstein. Einstein's 1905 paper, what I've been concentrating on. So there's a lot on there about that. You can find that there's one word different between the mistranslation and the correct translation, and you can write, it seems to be hundreds of pages on just the difference, because it changes the emphasis of the maths, what it meant by the maths. So I can talk about just that for ages. It's just a really totally awful translation of Einstein that we have been given as the usual translation of Einstein. It's just totally awful. It should be just been. It's what is taught as Einstein's relativity, but it's not what Einstein's really saying in German.
Besides the mistranslation, there are those who...
Sorry.
Did we cut out on that?
1, 2, and maybe the batteries.
Besides the mistranslation, there are those who accuse Einstein of downright plagiarism, copying from others. Is it a possibility?
Sorry, I'm breaking up. Sorry.
I think he said he's talking about plagiarism. What's your thoughts on that?
Yeah, that has been picked up by a lot of people because when you get Einstein's paper on special relativity, 1905, there is no references as to what he's working from, and so that would most people would okay, that would indicate plagiarism. You are using somebody else, but you're not citing who they are. But for some reason or other, Einstein was allowed to get away with publishing that in his science journal. So that gives the false impression that Einstein is totally new, but it's not totally new. He was working from earlier sources. And you can actually see his earlier sources if you try to dig in hard. I've got one of the sources did a thought experiment where he thinks about what happens if you travel at the speed of light. What happens if you look in the mirror and say, well, that actually comes from an earlier person. This person's book, Einstein had read. So people read Einstein thinking, oh, this is all you. This is Einstein's thoughts on things, but it's not. It's from what he's read. He's put all these things together. He's read all these things, put them together in his paper, maybe with the help of his wife. That's another thing people speculate. And he's not cited where he's got the information from. And nowadays, such a paper would not be published. You've got to cite your sources. But in 1905, for some odd reason, he was allowed to get away with that back then. The rules seem to be different then. So it's a big argument, is it plagiarism or not? What he was allowed to do then, you're not supposed to be allowed to get away with now.
You have one, Dan? Okay, go ahead.
Roger, this is Bob DeHilston. You made a comment that time continues when a man disappears. Did I get that right?
Sorry, okay. What?
Say it again, Dan.
Sorry?
You made a comment that time continued even though humans might be gone. Did I hear that right?
I don't think so. I was talking about Newton. He had the idea of universal time, and he also had the idea of relative time. And so this is something that people have been talking about for quite some time. People's perception of time individually, and the universal time out there can be different even back in Newtonian physics.
So I think I must have misunderstood, because I understand motion to continue, but the value of time at least is really recorded by man. So if man disappears and then comes back later, he can see things have moved, but he doesn't necessarily know how much time has lapsed because nobody's been keeping track. So it seems to me in that scenario, motion happens, but time is unknown, and you almost have to restart your whole new reference to time. So it looks like, oh, I see. That'll do it.
There we go again. Yeah, we're getting bad internet again.
Hello, yeah. Sorry, my link broke. I'll come back again. Yeah, there's a lot that can be said about time. I mean, roughly, I've kind of like skimmed over it, that the idea of time dilation is not unique to Einstein, and Newtonian physics would be happy with the idea as well. There's different types of time.
Yeah. Well, thank you for your talk. It was very interesting.
Thank you. It's basically everything we have been told is Einstein's relativity is really based upon its translation.
Let's see, I had a question. It's not coming to my mind now. Okay, I'll think of it. When the question of you looking, did you say, I wasn't understanding, Musa did ask about possibly you or someone coming up with a better translation, Did I understand? Is that something you're working at? Is that something that should be done? I didn't get that answer. I apologize if that's already been answered.
Well, I got this person, it was Crackler, he's fluent in German and English, and so I've gone by him. And I've also done the Google Translate. You can translate yourself German into English and compare it to the usual translation. And I'm quite much happier with Crackler's interpretation. I think it makes a great deal more sense to me. But usual translation, the one by Jeffrey and Herrick, I think they used to be known, that it doesn't make sense. You read it, and for most people, if you read that and you think, well, this is totally different to Newtonian physics, and that is just a mistranslation. With a better translation, it's more in line with what Newtonian physics is about. And then when you've got it being, well, this is continuing, Einstein is continuing on with Newtonian physics, well, maybe he's making mistakes with the maths as well.
I guess I do remember my question now was basically sort of on, you're doing something really like trying, and other people are too, to do historical reconstruction because Einstein in fact didn't leave references. We're left unfortunately to say, did he know about the Michelson-Morley experiment? Did his wife help him? Botchkovich. Yeah, you said that because of the wording, you saw some reference there. So you're really trying, we're really, and you are specifically trying to do I guess what they would call historical reconstruction here?
Yeah, that's right. You've got to know, really, you need to know how physics develops. You've got people like Chappell, Copernicus, Galileo, and then you've got people further on. And so Einstein, with the bad translation, it looks like, well, Einstein's completely different. But actually, you've got a development from all these people before Einstein. And so that the bad translation has broken that off. And so that's what I've been looking at. And I see it's more the natural progression of development. But sort of like everything's gone bad since 1905 or should say 1919. Everything's gone up pear-shaped. And it's all been based on a bad translation of Einstein.
Okay, thank you. Any more questions? Any more questions? Okay, well, thank you so much. We'll have, you want to wrap it up there, host, Mr. Franklin?
Well, I push on it and hold on to it.
Okay. No, okay, here we go. All right, well, thank you, Roger, for your presentation. And I think that concludes our conference for this year, CNPS 2019. And hopefully we'll see you all in next year.
2020.
2020, somewhere on the East Coast to be announced. All right.
Good job.